Your students will not remember everything you teach. That's just how the human mind works. The question we have to ask ourselves is, what tools do we have to frame the most important understandings in a given class, given that our students will not remember everything we teach? So, starting off with a quiz, and try to be honest with yourself. Do you know what two gases make up the Earth's atmosphere? Do you know who the 15th president of the United States was? Do you know the Pythagorean theorem? When I'm in audiences giving this professional development, most of the audience does not know the answer to any of those questions. About 25% tend to know the answer to what two gases make up the Earth's atmosphere, nitrogen and oxygen. About 20% know who the 15th president of the United States was, Buchanan, and about roughly 25% know what the Pythagorean theorem is, a squared plus b squared equals c squared. Now, it's not that we didn't all learn that information. At some point in 8th grade science, we all learned the two gases that made up the Earth's atmosphere, and I guarantee some science teacher told all of us that this is fundamental knowledge that you must have. At some point, we were all told that we had to memorize dates and important people and events within history. And at some point, we were all made to memorize the Pythagorean theorem. Now, that's not to say that any of this information is unnecessary. In fact, it's all very important. But it's only important as a means to a larger ends. And it tells us something that most of us, functional human beings, functional adults, don't remember minutiae unless we are within the field in which that minutiae is made to make sense, is used to make sense. So if you're a scientist, a climatologist, you are probably working with the knowledge of what the two gases are that make up the Earth's atmosphere on an intimate basis, on a constant basis, and therefore what might be minutiae or what might be discrete facts to somebody who is a historian are really important to your work. The same might be said of the question about the 15th president, and the same might be said of a mathematician or architect working with the Pythagorean theorem. So we have to be able to categorize certain types of information. And we have to be able to ask ourselves, what are the types of information that we can provide our students, and how are we having our students frame the discrete facts and skills of our disciplines within their means consequence, within the answer to why is this important, so what, why do I need to keep around this information? So there's a problem that contends with this in traditional education. And this is at the heart of understanding by design. First of all, there are two twin sins noted by the authors Wiggins and McTighe. The first twin sin is designing curriculum like an activity designer. Essentially, this is your teacher who designs what might be fun, enticing, engaging to students without first asking the question, what are my outcomes? What should students be able to do, understand, and know as a result of this unit? Rather, the question is, how am I going to get students engaged? There's nothing wrong with engagement, but engagement without defined outcomes is not what we're looking for in one of the twin sins. The other twin sin related to the quiz that you just took is the sin of coverage. And this is the idea that in August, when the school year starts, a teacher in 8th grade math or 9th grade science or 3rd grade literacy blocks simply grabs their students by the intellectual wrist and drags them through the school year, teaching and testing without deep application, without deep understanding for students. Wiggins and McTighe refer to this as teaching by mentioning. We're essentially teaching by mentioning throughout the school year as if that says anything about student capacity at the end of a unit or at the end of a school year. Part of the problem with coverage is that students are under the impression that everything taught is of equal value. This idea that there is no discernible hierarchy of information, or in another way of putting it, that there is no core information and that there are less core components of information that are used to then inform that core. More about that as we move through these videos. Instructors or teachers often don't take the time to frame the most important ideas. We don't take the time to answer the why and so what. We don't take the time to have the discussion of means consequence, of the application of the learned skill. This leaves students with the idea that facts and skills are to be memorized, that they're abstractions that are not connected to application, which is deeply problematic in terms of how we remember things as human beings. And the means, which are the discrete facts, and by the way, we're not throwing the baby out with the bathwater. The means are really important. So verb-noun agreement, the construct of a thesis statement, the Pythagorean theorem, all of these nitty-gritty facts that are taught in a traditional education are often emphasized as the ends of the education for students. In other words, memorizing the Pythagorean theorem is the ends of most education, most classrooms. The true ends are concepts that provide human beings with the ability to make connections, to make conceptual links between discrete facts. So the means, the discrete facts and skills, they're still very important, but only as a tool to use your mind well, only as a means to a larger end. So the paradigm shift asks us to consider a couple of things. Foremost, some content is more important than other content. So one way to think about this, and we'll exercise through this idea in future videos, is the 40-40-40 rule. And that's that in every class there are certain things that are important for students to know, be able to do for 40 days. So a classic example of this is who was the 15th President of the United States. You might need to keep that around for a little while, but for most of us, that is information that can be forgotten and you can still be a perfectly functional person. There's certain information that we need to keep around for about 40 months. And for most of us, that tends to be advanced high school math that is important for taking an ACT and to get into particular college classes, to clep out of some classes in college. We need it for about 40 months because we're going to see it again. But after that, most of us haven't seen the Pythagorean theorem since. And then there's the 40-year rule. And this is perhaps where we begin to distinguish between certain content that's more important than others. And when we say content in terms of the 40 years, we're mostly talking about understandings. Understandings that help us to make sense of many discrete facts and skills within a given discipline, or perhaps even in an interdisciplinary fashion. So the 40-40-40 rule will give you a framework with which to begin to think about curriculum development and placing emphasis for students on what's more important than other pieces of content. So instructors are obligated to frame the why and so what of study, otherwise known as big ideas or concepts. And that's where we really begin the process of building a curriculum framework, by asking ourselves, what are the big ideas that guide our discipline or guide the subset of discipline that we're teaching? What are the big ideas that guide Algebra 1? What are the big ideas that guide geometry? What are the big ideas that guide American history from 1856 to present? What are the big ideas that guide an English language arts course? And lastly, this idea that we've touched on a bit, and that's that knowing is different than understanding. To know is to be able to recall. To know is to be able to, for a student of mine, to tell me exactly what I told them in exactly the way I told it to them. It's a regurgitative quality. It's important, but again, it's a means to an ends. And the ends is understanding. Understanding is defined as a student who can take their learned fact or skill and apply, transfer, or use that skill in a novel setting, in a problem they've never seen before. In other words, can we kick off the training wheels and throw our students into a problem they've never seen? Can they float? Can they swim with their learned skills? Or do they not know enough in order to be able to maneuver flexibly with their learned skills in a novel problem? So how does all of this come together in understanding by design? There are 3 stages of UbD. The first stage is determining desired results. In this stage, we're asking ourselves, what are the outcomes and understandings? There's where the understandings piece comes in, not just the facts and skills. My students will take away from this course, this unit, or this lesson. By the way, UbD works in many time frames. So ideally, an entire course, or perhaps an entire school year, an entire school is backward planned from big ideas that frame the school, then big ideas within each discipline within that school, then big ideas within each course within that discipline, and down to the unit level and down to the lesson level. So the lessons of this 3 stages really should be applied at every level of teaching. For the purposes of what we're going to build with these videos, we'll focus simply on the unit level. So the question would be, what are my outcomes for my students, both content-wise and conceptually or within understanding, for this unit? And what tools do we have to frame the most important ideas for students? Stage 1, again, requires us to determine desired results. What are my outcomes of a unit? Once we've asked ourselves that, the next logical question is, now that I have my desired results, how do I assess for understanding? How do I know that my students understand? How do I know that they can perform with their knowledge? Can my students perform, transfer, apply, and use their learned knowledge given my outcomes that I defined in stage 1? And lastly, the question is, now that I have my outcomes and my assessments which allow me to evaluate student capacity in those outcomes, how am I going to structure the course? What does the day-to-day teaching look like? What should I teach tomorrow? What does Monday first period look like? What materials am I going to use? Am I going to use the textbook? What chapters of the textbook am I going to use? What formative assessments must I plan? This is where the real meat of the planning comes in this stage 3. But it's incredibly important to note that stage 3 is the last stage in the process for a reason. Prior to being able to ask ourselves, what am I going to do tomorrow, we have to be able to ask ourselves, what are our objectives? What are my objectives for this unit or for this school year? Otherwise, planning can be episodic for students. It can be moving through a textbook or moving through a set of skills that are seemingly unrelated for students, and we never make the connections for students. So you move from one isolated skill to the next isolated skill to the next isolated fact without any coherent curriculum plan. Hence the importance of a 3-stage process. The last component of this is to put it all together. And there are many facets of that, and those are the subject of future videos. So coming back to that big understanding, your students will not remember everything you teach. That's how the human mind works. So what are those tools we have to frame the most important understandings in a given course, a given unit, a given lesson for students?